Welcome to Database Data Types. Just like people distinguish different types of data by a corresponding symbol, a $ for U.S. currency, a percentage sign for percentage numbers, and a colon and AM, PM for time, computers use different types of internal code to distinguish between different types of computer data. In this learning object, you'll understand how programmers use data categories to identify different types of data. In most relational databases, all columns, parameters, variables, and expressions have a specific data type. Data type is an attribute that determines what kind of data can be stored in the column or variable, the range of the value that can be entered into the column or variable, and what operations are allowed on that data. Why is the data type needed? It saves disk space. If you know ahead of time you're only going to store small numbers in the column, you wouldn't use data types intended for large numbers, which allows you to minimize the database size. It speeds up database operations. Smaller data footprints in memory and rules applicable to each data type allows for database management systems to use optimal data processing, which significantly improves performance. It ensures data integrity. Specific requirements for each data type prevent you from adding oranges to apples or multiplying dollars by customer names. There are 7 data categories used by programmers. These are: select each data category to learn more. When choosing a numeric data type, you need to ask yourself a couple of questions. What type of data is expected? Is it a weight, a date, or currency? What is the largest number ever expected to be contained in this field? Lastly, what are my plans for this data? Will calculations need to be done? Will I count the results? Do I need to capture granular details? Each category has a specific purpose. Because most programming languages require a programmer to declare the data type, it's important you select the correct category before building your tables. Let's say we own an online retail store, GameStar Systems. We need to write a database that supports online ordering, including the date and time the order was placed, the currency used for each order, and the Unicode characters we'll need for customer names. For our online store, we receive hundreds of orders per minute, and we need to ensure customers receive their packages in the order they were placed. To do this, we need to keep track of the date and time each product is ordered. First, we choose the date and time data type, and then we determine which one is right for this scenario. The best choice for our orders is datetime 2 with a precision of 7, because it provides the most granular detail of time precision. It allows us to capture product order times to the nanosecond. Next, we need to input monetary value to my product. We could choose small money or money. If we were selling candy, small money would fit the bill. However, if we were selling houses, small money would only allow us to see houses less than $214,748. Using money is far less restrictive and lets us see larger figures. For our website, we'll use money in hopes our customers place really large value orders. Currency can also be stored using decimal or numeric data types, both of which are also good data types for storing a weight measurement. Each of these data types are supported equally in SQL. However, they have slight distinctions. For example, money data types allow using dollar or other currency signs as part of the value. Decimal allows storing larger numbers than money type. Which type to use is a matter of programming environment requirements, the personal preferences of the programmer, and common sense. The rule of thumb is to use money types exclusively for currency, and decimal types for other numeric data, for example, tax rate. These data types support something called precision and scale. Precision is the total number of numerals to the right and to the left of the decimal. Scale only includes the numbers stored to the right of the decimal. For example, if we want to store 5 numbers and 2 of those are on the right side of the decimal, we'd use numeric with a precision of 5 and a scale of 2, which would look like this: 300.00. Remember, the decimal data type is just like numeric. And if we want to support the number 1000.50, we would choose decimal with a precision of 6 and a scale of 2. Character data types have a little more flexibility, but looking toward the long-term use of a table, incorrectly choosing a data type early on can add more work when data conversions are required. The best choice is to make the correct decision at the beginning of the project. We also need to determine if we'll use Unicode characters, which allows fields to support accenting and foreign characters. Even though our business is local, we should consider the words needing this support. What happens if Marina Ivanova places an order with our company? To support the Cyrillic name, we'd use the data type Varchar or Char. In this case, we'd choose Varchar. Let's find out why. We need to determine how many characters to allow in any particular field. Leaving room for a 75-character name means assigning the data type Varchar with a precision of 75. Using this data type means we can fit 75 characters in this field, but we may not use all of them. In the case of Mr. O'Nally, we'll only use 7 characters and save the unused character spaces. If we had chosen to use Char with a precision of 75, all 75 characters would have been used, and in absence of characters, it would be padded with spaces, taking up valuable storage space. Some older software requires exact placeholders, so this data type does have a place and a use. What about Varchar and Char? When should these be used? Understanding the data to be contained is important. When creating a list of U.S. states as a part of the addresses used for our online business, we'd be safe to use Varchar. There's no accenting or foreign characters needed, and the data is fairly static. To determine the length required for the state field, we use the longest U.S. state name, Massachusetts, at 13 characters long, and write the data type result for U.S. states as Varchar with a precision of 13. Today, you were introduced to database data types and how programmers use those types when programming tables. You also gained an understanding of why this is important through our online retail example. It's critical to understand the type of data you need to enter into a field, including the length of any future data. Think forward when creating your fields and tables and pick the right data type from the beginning. You've completed database data types.